Hello everyone and welcome to another episode of Interstigation. In today's episode of Interstigation, we're finally moving on to 2021 Fall AMC 10B. And in this video, I'll go over the first 10 problems. Let's get the easy problems out of the way first, and going on, I will publish one video per problem dedicated to that problem to explain you how to do those problems. So let's get started with number 1. Number 1 simply wants to find the value of this arithmetic expression. We can see that on each place value, 1, there's 2, there's 3, there's 4, which means that on thousands place value, which means that each digit represents, let's say 1 here represents 1 times 1,000, 2 represents 2 times 1,000, and so on, which means that for each digit, if we see for hundreds digit as well, 2, 3, 4, 1, just in a different permutation, but it's always 1 plus 2 plus 3 plus 4, which means that our sum would be 1 plus 2 plus 3 plus 4, and that multiplied by 1,000, and also 100, because it also happens on the hundredth digit, and also 10th digit, and 1st digit, which means that it is 10 times 1111, which gives us 11110, or the answer choice E. Moving right on to number 2. For this problem, we can see that, this figure is symmetrical on the left-hand side and the right-hand side. So what does that tell us? That tells us we can just calculate the area of one side and multiply that by 2. Well, the area of one side is simple because it is just simply a triangle, which means that here this side has side length of 3, don't count it wrong, and has a height of 2, which means that the area is 3 times 2 divided by 2 and multiplied by 2 because we have 2 sides, which means that these 2 cancel out, we get 6, or answer choice B. Moving right along to number 3. Number 3 states that the expression this is equal to the fraction this, in which P and Q are positive integers whose greatest common factor or divisor is 1, which means that basically it wants us to find P over Q, and it basically only wants P, but in a form of P over Q such that it is in the simplest form. Well, we don't know what the simplest form is, so let's just find the common denominator. The common denominator is 2020 times 2021. The numerator is 2021 times 2021 minus 2020 times 2021, and that is going to be 2020 times 2020. If we combine that, because we have the same denominator, we can subtract that. We get 2020 times 2021, and that will be 2021 squared minus 2020 squared. We can then use the difference of squares formula to get 2020 times 2021, and the numerator is going to be 2021 plus 2020 times 2021 minus 2020. Well, that is just going to be 1, which means that our numerator is 4041. And if you're not sure whether or not this is the simplest form, we can also write this as 4,000 or 2 times 2020 plus 1 over this. Which means that, because this and this is plus 1, and even if there is a number, let's say 2020, that is divisible by this, plus 1 after that it wouldn't be. And for 4041 can also be written as 2 times 2021 minus 1 as well, which means that that is going to be the simplest form, which means that our answer is going to be E. Alright, now let's take a look at number 4. At noon on a certain day, so that's 12 o'clock, Minneapolis is n degrees more than St. Louis. So just to keep track of the two names, it's Minneapolis and St. Louis. At 4 p.m. or 4, the temperature is in Minneapolis has fallen 5 degrees. And the temperature of St. Louis has risen by 3 degrees. At which the time of the two cities differ, keyword differ, by 2 degrees. Well, let's see. If it is 10 degrees and at the end we're just comparing the relative temperature, let's just set one of them to be equal to 0. Let's say St. Louis has a temperature of 0 at 12 o'clock, and it follows that at 4 o'clock it has risen by 3 degrees, so that has 3. And Minneapolis, that would have a degree of n, and at 4 o'clock it will have n minus 5. And we want the temperature differ. You'll say, oh, that's n minus 5 minus 3, that is equal to 2. Well, that is not exactly right, because it actually hints us that is not right by the word product. It means that it is likely that there are going to be more than one solution. Well, if we take a look, differ, it doesn't say if it's St. Louis has a higher temperature or Minneapolis has a higher temperature, which means that it is the absolute value of this, which means that absolute value of n minus 8 is 2. One case, n minus 8 is actually 2. We get n is 10. And the other case is n minus 8 is negative 2, in which we get n is equal to 6. Well, the product of 10 and 6 is simply just going to be equal to 60, or answer choice C. Alright, now let's take a look at number 5. It is a really simple question. It just gives you this, and we want to find the value of this. Well, 8 to the 22nd power and divided by 4. I don't really see a way that we can calculate this directly, so let's just make them into the simplest possible, which is 2. Well, 2 to the 3rd power, 2022, 2 squared. That is 4. Which means that on the numerator, that is going to be 6,066, and the denominator is going to be 2 squared. Which means that we would get a final result of 2 to the 6,066 minus 2, which is 2 to 6,064. But we see that the only choice that has base 2 is B, and that obviously is not our answer, which means that we can cross this out. And let's take a look. Well, 8, that times 3, okay, if we want to convert all of the answer choices to base 2, that might be a lot of work, so might as well convert this into base 4. Well, if that is in base 4, then we get 684, and we want to turn it into base 4, which means that 6,064, we need to divide that by 2, and we get 3,032, which means that we get our answer choice E. Now let's take a look at number 6. Number 6 says there is a positive integer with exactly 2021 distinct positive divisors, and can be written in the form of that, and we want to find this. Well, we want to find the least positive integer with 2021 distinct positive divisors. We need to factor 2021 first. Well, if we factor 2021, if you don't know the factor, let's say the least, let's say the perfect square around it. Well, we see that is 2025 minus 4, and we can use the reverse of difference of squares. We get that is 45 plus 2, 45 minus 2, which gives us 47 times 43. And both of these are indeed primes. Well, let's see. Let's take a smaller example first. Let's say 12. Well, if 12 is 2 squared times 3, then let's say for each factor, then it could have 2 to the 0, could have 2 to the 1, could have 2 to the 2. And similarly, it could have 3 to the 0 or 3 to the 1. And that is going to be 3 to the 1 power. And that has 3 choices because it can be 2 to the 0, 2 to the 1, 2 to the 2. And this has 2 choices. Just reconsider again, we don't have to subtract anything because even if we have 2 to the 0 times 3 to the 0, that is 1. That is also a divisor. If we have 2 squared times 3 to the 1, that is going to be 12. That is also a divisor of 12, which means that 12 has 6 divisors. So we can generalize this. Let's say if a number m can be factored to p1, a1, p2, a2, all the way to pn, an, then here it will have a1 plus 1 traces because it will have 0, 1, 2, all the way to a1. And here it will have a2 plus 1 traces and all the way here to an plus 1 traces. Well, the number of choices together or the number of divisors will just be all of these multiplied together. Well, here, because we know that a1, a2, all of these as a prime factorization, all of these are going to be positive integers, which means that this is the only way. Or we could have, that could be equal to 1 times 2021. But, that is not really, because there will be some prime to the 2021. That is going to be very large. And for this, we would have p1 to 46th power because 47 is a1 plus 1. That times p2 to 42nd power. Which means that here we would have p1, p2. Well, we want this number to be the smallest. Obviously, for p1 and p2, we want to use 2 and 3 in some order. But we see that if we have, let's say, if we factor that will be p1, p2, that to the 42, that multiplied by p1 to the 4th power. Well, this thing is going to be the same whether p1 is 2 or p2 is 2. But this, 2 to the 4 or 3 to the 4. Obviously, this one is smaller, which means that we want p1 equals 2. Therefore, our number would be 2 to the 46 times 3 to the 42. And what does it want? It wants us to write in the form of m times 6 to the k. Well, we can use this form over here. We get 2 times 3 to the 42 times that p1 to the 4th, which means it's 2 to the 4th. That's 16 times 6 to the 42nd power. And that will give us 16 plus 42, which is 58. That is our answer for this problem. Let's take a look at number 7 now. Co-fraction a over b, and it specifies that it does not have to be in the simplest form. If a and b are positive integers whose sum is 15. How many distinct integers can be written as the sum of 2 not necessarily distinct special fractions? Well, let's think about it. How many distinct integers? Well, we want integer as the sum of 2. Well, let's just list out every single fraction because it says a and b are positive integers. We have a, let's say 1, that will be 14, 2 over 13, 3 over 12, 4 over 11, 5 over 10, 6 over 9, 7 over 8, 8 over 7. That will be 9 over 6, 10 over 5, 11 over 4, and 12 over 3. 13 over 2, 14 over 1, and 15 over 0. That doesn't exist because we want b to be positive. And let's group them. If we think about it, if we have two fractions, well, if C and D are different and they are in the simplest form. Let's think about this. Well, this will be CD AD plus CB. We're told that these are in the simplest form, which means that this could cancel out. But A times D, well, A doesn't have any divisor in C, and D, well, that we can assume that doesn't either. Well, if we think about that, that will not be divisible by CD, or that wouldn't be divisible by C straight up, which means that this cannot be simplified into an integer. Well, with that being established, we can just combine everything with the same denominator. And that is the only way that an integer may be created. So 1 over 14, 2 over 13, 3 over 12, that is 1 over 4. We have 4 over 11, 1 over 2, 2 over 3, 7 over 8, 8 over 7, 3 over 2, 10 over 5, that is 2. 11 over 4, that is just going to be something over 4, 11 over 4. And we have 12 over 3, that's 4, 13 over 2. So 13 over 2, 12 over 3, no, that is 4. Excuse me here, that is 4. And we have 14 over 1. Well, let's see, we only have to compare horizontal rows now. If we double 1 over 14, we get 2 over 14. That is not an integer. If we double this, we get 4 over 13. That is not an integer. If we double this, we get, well, 4 over 2. That is not an integer. If we double this, we get 22 over 4. That is not an integer. If we add them, we get 3. That is an integer. If we double this, we get 8 over 11. That's not an integer. If we double this, we get 1. If we double this, we get 3. If we double this, we get 13. Well, if we add them up, like 2 by 2, we get, well, 1/2 plus 3 over 2. That is going to be 4 over 2, which is 2. 16 over 2, which is 8, and this combined, which gives us 7. And this double, that wouldn't work. If we have this double, that would be 14 over 8, that doesn't work. That would be 16 over 7, that doesn't work. And here, any combination will work. So that would be 4 double 2, 4 double 8, or double of 4 is 8, and double of 14 is 28. And we can add them to, that would be 6. Add this, that would be 16. And add this, that would be 18. Let's take a look. Don't just count them up, because some of them do repeat. So 3, that repeated. And I see 8, that repeats. And just scan 3 of them once. And make sure that nothing repeats. And we'll count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, which gives us answer choice C. Alright, moving on to number 8 now. The largest prime factor of 16,384 is 2, because that is equal to 2 to the 14, and we want to find the largest prime factor of 16,387 or 383. 16,383, that is equal to 16,384 minus 1. I think all of you can agree on that. And they gave us that is 2 to the 14 minus 1. We can now use the difference of square. We see that is 2 to the 7th squared minus 1 squared. And that is 2 to the 7th plus 1 times 2 to the 7th minus 1. Well, 2 to the 7th, that is just going to be 128. That is not really hard to memorize. And even if you don't memorize that, you will be able to calculate that pretty easily. Just waste like 20 seconds. It isn't a really big deal. We have 129 times 127. or 129. That's obviously going to be divisible by 3. So let's just divide it out. 129 divided by 3, 43. So we get 3 times 43. That is a prime. So we have at least 40-ish times 127. Now, let's think about how to factor 127. Well, 127 doesn't divide 2, doesn't divide 3, doesn't divide 5, 7, 11, and 13. Well, upon to 13, you see that 13 times 13 is already 169, and that if we have something, let's say 13 times n, that is equal to 127, or something even larger, then n is less than 13. Which means that we would have already tested it before that, because we would have tested n, and n would be that. So you only have to test until the greatest integer less than the square root of 127. Well, now we can confirm that 127 is indeed a prime. Is a prime, which means that it wants us to find the sum of the digits, which is 1 plus 2 plus 7, which gives 10, or C as our answer. Moving on to number 9. Well, the knights of a certain kingdom come in 2 colors. 2/7, or 2/7 of them are red and the rest are blue. So let's see. Red and blue. Total, and here we go, this is total, and we have something here. Furthermore, some of them are magical, and I'll assume the other are not magical. Well, the total red, that is going to be 2/7, and this is 5/7. And the fraction of red knights who are magical is 2 times the fraction of blue knights who are magical. What fraction of red knights are magical? Well, this is one. Well, let's think about it. This problem, I think, honestly, it's worded very weirdly, and I don't like this problem. I think it is kind of the hardest problem from the top, the first 10 problems, but there is still a way to solve that pretty neatly. The fraction of red knights who are magical. So the fraction, let's say this is x, so the fraction will be x divided by 2/7. Who are magical is 2 times the fraction of blue knights who are magical. Well, let's see. If we have this as a, then we can see that x is just 2/7 a, which means that if we have that, then our magical spot will be 2/7 a. And who are magical is 2 times the fraction of blue knights that are magical. Well, if we think about it, that will be x divided by 5/7. That is going to be 1/2 a. Well, the a, I didn't set it up really well. We can have this as 2a instead. It wouldn't impact that much, but it will look cleaner. So that wouldn't be x anymore because we already used the x variable. To avoid ambiguity, I would put this. So 7/5 a. So that would be 7/5 a, and over here, this is going to be 4/7 a. What fraction of red knights are magical? Well, if we think about it, we would have this as 2 times magical. We see that 1/6 of the knights are magical, so that will be 1/6. So 4/7 a plus 5/7 a is equal to 1/6. We get that 9/7 a is 1/6, which means that a is 1/6 times 7 over 9, which will give us 54, or 7 over 54. So you can replace that. But what we actually want to find is this 2a value, because it wants us of blue, the fraction of blue that are magical. So we want 2a, which is 7 over 54 times 2, which gives us the answer of 7 over 27, or the answer choice C. Well, now let's take a look at the final problem that we're going to look at in today's video, which is number 10 in 2021 for AMC 10B. To reiterate, well, this one just seems very wordy and kind of hard to solve, but it is actually not that hard. Well, 40 slips from 1 through 40 are placed in a hat, and there is an important keyword without replacement. Alice says, I cannot tell who has the larger number, which basically means that Alice does not have 1 nor 40, because if he has 1 or 40, then that means he's going to know. If he has 1, then he has a smaller number. If he has 40, then he has the largest number. So he does not have 1 or 40. And Bob knows that. So he says, I know who has the larger number. Well, if he knows he has a larger number, it's either his number is really small, let's say 1, then he would know Alice has a larger number. Well, Alice wouldn't know. If he has a number that is very big, then the same thing happens. He will have the larger number, and Alice wouldn't know who has the larger number. But since Bob now knows that Alice does not have 1 nor 40, which means that he can also have 2 or 39. If he has 2 and he knows that Alice doesn't have 1, then Alice's number must be larger. And same logic applies for 39. And that's the only 4 numbers that Bob could have. Now Alice says, you do? Is your number a prime? Now Bob replies, yes, my number is a prime. And the only prime in the 4 numbers that we listed is 2 itself. Now, if I multiply your number by the result is a perfect square. If we multiply this number by 100, we get 200 plus Alice's number, I'll just use a. That is equal to a perfect square. Let's say k squared, where k is integer. That just basically means k is an integer. And let's think about it. Well, we know that Alice is 1 through 40, or in fact, it's not 1 through 40. It is going to be 3 through 39. Well, if you think about it, just let's say k is 10, then k squared is 100. That's nowhere near 200. If we have 15, that would be 225. That seems to work. Well, if we insert something before it, let's say if we insert something like, let's say 14, that is 196. Well, that doesn't work. If we have 16 squared, that is going to be 256, and that is larger than 39 as the limit, which is not gonna work. So we have 200 plus a is equal to this only number that could work is 225, which means that a is 25. And thus, the sum of the 2 numbers, Bob has 2 and Alice has 25, which if you add them up, you would get 27, or A as your final answer. Thank you for watching this episode of Interstigation, and I will post more videos on the entire fall AMC 10B test, and stay tuned for that if it hasn't been uploaded already during the time you watch it. Other than that, goodbye and have a great day. Enjoy math.